This is a 25-story luxury apartment tower in Milwaukee. From the outside, it looks like almost every skyscraper built in the last century: steel, concrete, and glass. But let's look inside. The beams holding up the ceiling are wood. The columns are wood. Above its concrete base, much of the tower is built from engineered timber, and it is not the only one. In Norway, Sweden, Australia, and Japan, architects are racing to build taller and taller buildings out of a material we mostly abandoned for big cities over a century ago. Which raises the obvious question: is this the future of our cities, or just incredibly expensive firewood? For most of human history, we built with what we had. Wood was available, flexible, and strong enough for homes, barns, bridges, and entire towns. But wood had one fatal flaw: it burns. After historic fires devastated cities like London in 1666 and Chicago in 1871, the world became terrified of wooden cities. Building codes changed. Large structures moved away from timber. And to build higher, denser, and supposedly safer, humanity turned to three materials: steel, concrete, and glass. Those materials gave us the modern skyline. They allowed cities to stretch upward and hold millions of people in dense urban centers. But they came with a massive hidden cost. Concrete and steel are among the most carbon-intensive materials on Earth. Producing them requires enormous amounts of heat, energy, mining, transportation, and chemical processing. A single large building can carry thousands of tons of embodied carbon before anyone even moves inside. But wood can change that. A tree absorbs carbon as it grows, and when that wood is turned into a building, much of that carbon can stay locked inside the structure for decades. So instead of only adding emissions during construction, mass timber can turn part of the building itself into long-term carbon storage. That leads to the real engineering question: how do you make wood strong enough to support a skyscraper? You do not use regular lumber. You use mass timber. Mass timber is basically engineered wood built for serious structural strength. The most important version is CLT, or cross-laminated timber. It is made by stacking layers of wood in alternating directions, then pressing them together into massive panels. That makes the wood stronger, more stable, and able to replace concrete floors in many buildings. Then there is glulam, or glued laminated timber. Here, the wood layers run in the same direction, creating huge beams and columns strong enough to replace steel in many parts of a structure. And there are newer options like DLT and NLT, which use wooden dowels or nails instead of glue to lock pieces of the lumber together into solid structural panels. The result is intricately designed Lego set for a building. These massive timber pieces are designed digitally, cut to exact specifications in a factory, and shipped to the construction site ready to assemble. Instead of pouring concrete floor by floor and waiting for it to cure, workers can lift entire panels into place like pieces of a giant kit. That can make construction faster, cleaner, and quieter. Because the wood is lighter than concrete, the building can also require a smaller foundation. And on-site, there is often less dust, less welding, and less heavy material waste. During the construction of the Ascent Tower in Milwaukee, workers even described the site as smelling less like chemicals or exhaust and more like popsicle sticks. That small detail gets at something bigger. These buildings do not just perform differently, they feel different. Exposed timber gives interiors a warmer, more natural atmosphere than concrete or steel, and some research suggests that natural materials like wood can make indoor spaces feel calmer, more restorative, and more connected to the living world outside. But we have to address the elephant in the room. If a fire starts, does the whole building go up in flames? Counterintuitively, no. Mass timber behaves very differently from ordinary wood because of something called char. When a massive timber column is exposed to extreme heat, the outside layer blackens and forms a thick protective crust. That char layer acts like insulation, slowing the fire down and protecting the solid wood inside. It is the same reason a huge log in a campfire does not burn the same way as a handful of twigs. The outside chars, but the center can remain structurally intact for a surprisingly long time. To prove this to regulators, engineers have put mass timber columns through intense furnace tests. Under extreme heat, unprotected steel can lose strength and begin to buckle. But properly designed mass timber can maintain its shape because the char layer burns at a predictable rate, allowing engineers to design extra material around the structural core. That does not mean timber buildings are fireproof. Nothing is. But it does mean that they can be designed to meet strict modern fire codes, just like steel and concrete buildings, and the proof is already standing. In Milwaukee, the Ascent Tower became one of the most visible examples of tall mass timber constructions in the world. In Norway, the 18-story Mjøsarna Tower showed that timber could rise far beyond low-rise buildings. In Portland, a massive mass timber roof now spans part of the city's international airport, showing that this material is not just for apartments. It can shape public infrastructure too. More timber towers are planned in cities around the world, from Europe to Asia to North America. Some are modest, some are experimental, and some imagine futures where wood, steel, and concrete are combined in new ways to reduce the carbon footprint of urban growth. But mass timber is not a perfect solution. It still faces real limits. Supply chains are tight. Building codes are still catching up. Moisture, mold, and long-term durability have to be managed carefully. And the environmental benefits only work if the wood comes from responsibly managed forests. There's also a structural limit. The tallest timber towers often still rely on concrete or steel cores to handle wind, elevators, stairwells, and lateral forces. So wood is not going to replace every material in the building. But that's not really the point. The point is that for the last century, building upward almost always meant relying on some of the most carbon-heavy materials on the planet. Mass timber gives architects and engineers another option. Not a perfect one, but a powerful one. It allows cities to grow with materials that are lighter, renewable, and capable of storing carbon instead of only emitting it. So maybe the future skyline will not be made entirely of wood, but it definitely won't be made entirely of concrete and steel either. If you enjoyed this video, drop a comment and subscribe for more videos.